Okay? Now, in mathematics, we often learn about things called functions. Functions are y equals to fx, where this fx is our function, right? Y is our output, x is our input. Now, it really doesn't matter what x is, right? It really doesn't matter what the function is. The function of the graph, if I never even tell you what it is, let me tell you that it looks something like this. I use a color blue. I say that it looks like a zigzag line like this. I don't even know how to graph this particular function. I don't know. Okay? But let's say it looks like this blue color thing. Okay? When we are talking about translation of graphs. Translation of graphs means I'm going to shift and move the graph. Okay? When I have the particular function fx plus 2, I want you guys to think about this. When I have fx plus 2, it means that the entire function fx will be shifted by 2. Correct? So you should know that if it's plus 2, that means this particular function, let's say if this is at 1, I will need to move this entire function up until it becomes 3. That is what it means by plus 2. Right? I think this is quite easy to understand. But where it gets a little bit confusing is that the input, okay, the input x over here has a little change. Let me give you an example. Let's say I have the original function fx, but instead of having as fx, I have fx plus 2. So in this case, can you see that it is not the function, it's not the entire function being shifted up, but rather it is the input value that changes by 2. Can you see that? So there is a difference. Okay, there is a difference. Okay, many of you see that, hey, what's the difference? There's a plus 2. But you must see where the plus 2 is added. In this case, the plus 2 actually directly affects the result. Why? Because the final result is raised by 2. But in this case, it is actually affecting the input. Okay? So let me give you an example right now. When we study the exponential graph, we have it in the function y equals to a to the power of x. And let me give you some concrete examples. Y equals to 2x. So we know that y equals to 2x is going to, y is here, x is here, is going to be an exponential function that looks like this. Correct? So this is the shape of the exponential function. And of course, the point at which it cuts the y-axis, when we let x equals to 0, we know that the value of y is what? What do you think the value of the y is over here? 1, right? Because when you substitute x equals to 0, anything raised to the power of 0 is equals to 1. If I have plus 2, what does it happen? This whole thing will shift up by 2 units. I think this one is quite easy to understand. But this is not what I'm interested in. If I have x plus 2 over here, can you see now what has changed is not the output directly, but the input. This is our fx. Because this is the same as saying that fx is my parent function to the power of x. So when I have a fx plus 2, it becomes x plus 2 over here. Can you see that? This is something that you must understand, and it's very confusing for many people who are doing translation. Translation is basically the shifting of graphs. Okay? So, in summary, when I have, when my input is being shifted by 2 plus 2, this is a bit different from the above. If it's plus 2, intuitively you may think that it shifts to the right, but it's not. If it's plus 2, means it shifts to the left. Okay, the whole graph is shifted to the left by 2 units. Okay, if it's minus 2, then the whole graph will be shifted to the right by 2 units. That's all you need to remember. Okay, and this is tested. No matter what graph they give you, whether it is exponential graph, whether it is logarithm graph, whether it's sine, cosine, tangent, okay, which you are going to learn how to draw the graphs of cosine, sine, and tangent, okay, later in the year. Alright? You must make use of all these properties. Okay? So you must know, does it affect the input or does it affect the output? If it affects the output, it is a shift on the horizontal axis, on the vertical axis. If it's a change on the input, then it's the left and right. Alright? Horizontal axis. Alright? Okay, let us go back to our question over here. Don't worry, we'll revise that over later. Okay, we left off over here, so I taught you guys about some manipulation, but maybe let me just redo this part again because I suspect some of you were quite confused. I actually rushed through this portion. Alright, now, they asked me to express t as a function of t. Now basically this thing is saying that I want t to be the subject of my formula. Okay, so something that is similar, something that you have done before. But because this is A math, things get a little bit confusing. Alright, now the equation that we have is of the above. So I'm going to rewrite this equation down here. T is equals to 20 minus 38e 0.6t. Now I want to make this little thing here the subject of the formula. So I understand from my secondary 2 days that if I want to make something the subject, it must be alone by itself on one side. Okay? Does it make sense? I want it to be alone by itself on one side. So I'm going to do that. But if I want this to be alone, I'm going to bring this 20 over first. So I'm going to bring this 20 over. So I'm going to get t minus 20 is equals to negative 38e negative 0.6t. And what I'm going to do is I'm going to divide both sides by negative 38 because I'm going to try to simplify it. Alright, because now here looks very complicated. I'm going to try to simplify this thing. So I'm going to divide both sides by negative 38. So if I divide both sides by negative 38, here is negative 38. Okay, this negative 38 and negative 38 will cancel. When you have a t minus 20 divided by a negative sign, actually this whole thing will flip in direction, right? Because it's the same as multiplying this by negative. Negative t plus 20t is the same as 20 minus t. So we have 20 minus t over 38 is equals to e negative 0.6t. I'm going to stop here for a moment. I need to think now, how can I, now this t is in a power, right? And I need it to be down here. I cannot have it in a power. If I want to make t the subject, I cannot have it in a power. So you need to think about it. There is one function that you have learned, okay? You have learned one function that you can bring this down. And that is our logarithms, alright? And we want to log both sides such that this is the same as the same base of your log. Why do you want to do that? Because you want to cancel this e away, okay? So the strategy that you thought about is to log e to both sides, okay? Why? Because we want to make use of this property. Please write down this property if you don't know. Log e of e is equals to 1. As long as these two numbers are the same, okay, as long as these two numbers are the same, it becomes 1. Okay, so we know that what we can do is we can log base e, 20 minus t over 38 is equals to log base e, negative 0.6t. This power can be brought down here, and log e base e will give us 1. Okay? So we know therefore that negative 0.6t is equals, log e can just be written as ln 20 minus t over 38. Anyone confused at this juncture? Anyone confused at this juncture? No, huh? Okay, then just one more step. In order for us to make t the subject, we divide both sides by negative 0.6. Okay, so I'll divide both sides by, so my final answer is just ln 20 minus t over 38 divided by negative 0.6. Of course, we can bring this up, I can just take 1 divided by 0.6. I will be getting -5/3 ln 20 minus t over 38. Is that okay? Okay, anyone confused? How do I get 5/3? In front of this ln is just 1. 1 divided by -0.6 is -5/3. Okay? Anyone can accept? Okay, that's how I make t, the small t, the subject of the formula. And this property is very important. Okay, this property is very important. Alright, if you do not know this property, you're going to find that it's going to be very difficult to solve some of the problems. Okay, let me show you some examples. I know it's not written over here, but let me see if there's any space. Do you have like a blank piece of paper right at the back, or any space? No, I don't have. Okay, never mind. We go to the next question first, then we see later. I'll give you some examples once we are done. Alright, explain why the temperature of the chicken can never reach 20 degrees Celsius. Why? Just look at this formula. Why the temperature of the chicken can never reach 20 degrees Celsius? Why? You see, for it to reach 20 degrees Celsius, right, it requires this whole thing to become what? 0. But can this become 0? Okay, why cannot become 0? Of course, I say like that, you sure no lah, no lah, but you obviously so it's no lah. Right? But why? Why cannot become 0? Okay? If you were to sketch out this graph, and I think we did sketch out the graph in above, right here. Right? Can you see here? In this case, if you sketch it out, okay, it never becomes 0. It approaches 0, but it never becomes 0. In fact, I want you guys to try. If you substitute a value of t over here, right? I just need you to try to enter what the value of this thing is. Let's try to make t a very large number. Let's make t 1,000, right? So if you enter in your calculator, -38, you have the e, -0.6 times 1,000. Okay, on your calculator it may appear like 0, actually it's not 0. It's very, very, very close to 0. Okay, it's very, very close to 0, but it never ever touches 0. Alright? On your calculator it will show you 0, but because your calculator simplifies certain things. Alright? But the truth is, it will approach 0. So your graph will look something like this. Okay, your graph will look something like this. It will go closer and closer and closer and closer and closer to 0, but it will never ever touch 0. We call this the asymptote. Right? It goes closer and closer and closer to it, but it will never ever touch it. Okay, that is one thing to know about exponential curves. Okay, why? I want you guys to think about why. Okay, because when you think about exponential graphs, right? Let's look at the decay function over here, the green color one. Okay, we talk about the green color one. I use this one to actually explain to you because actually the negative version is just a reflection. So if you can understand this one, you can understand why it never touches 0. Okay, I give you a scenario. Okay, let's say you have okay, the example not very good. Okay. Let's say you have a bacteria. No, actually bacteria is not a very good example for you to really understand. Okay, because you might have some misconception. Let's say you have let's say you have a piece of paper. Okay, let's say you have a piece of paper and your goal is to keep carrying the piece of paper into half and then throw it away. Alright, so it's definitely an exponential decaying function, right? The amount of weight of paper that you have. So let's say I have this piece of paper initially. I tear it into half. Okay, so it suddenly from weight it drops to half. I tear it again and it becomes even smaller. I tear it again, it becomes even smaller. I keep tearing and tearing and tearing and tearing and tearing. But every single time I tear, it becomes smaller by half. But will it ever become 0? No. Because it will become smaller and smaller and smaller and smaller and smaller. Yes, it approaches 0. It may look like it's 0, but even how small the number is, let's say it's 1, I divide by 2 becomes 0.5, 0.5 divided by 2 is 0.25, 0.25 divided by 2 is 0.125, 0.125 divided by 2. It goes on and on and on and on. It will never ever ever become 0. Okay? So you must understand the concept of exponential. It will approach 0, but it will never become 0. Okay, so that is the reason why, in this case, the temperature of the chicken can never reach 20 degrees Celsius is because negative 38e raised to the power of negative 0.6 T approaches 0 but never reaches 0. Okay, that's the key thing that we're looking out for. It approaches 0 but it never becomes 0. Okay, that's the reason why it will never become 20 degrees. Okay? That is the key thing about exponential functions. Okay? Okay, I'll give you some time to write that down. I repeat again, for those of you who didn't get it, it's because this exponential function approaches 0, but it will never reach 0. Okay, it will only approach 0. Alright, let us now go to the last one. And your exam, one of these questions will come out. Okay, but it's very simple. Come on, it's very simple. Okay, let's look at the next one. A man buys a new motorcycle. After T months, its value is given by V equals to blah blah blah, where P is a constant. Find the value of the motorcycle when the man bought it. Okay? So the question that you have to ask yourself is that when the man bought the motorcycle, what variable do you know? P is a constant, that means it never ever changes, it's just a random number that you don't know what it is. V is the value that they want you to find. So T, right? The variable T is the only thing that you could change. When the man buys the motorcycle, what do you think the value of T is? 0, because he just bought the motorcycle. Does it make sense? Okay, so this is the thought process that must go through your mind. And I can tell you 99.9999% of the time, the value of T is always 0. Okay, so if you really read the example and you don't really know what's going on, just let T equals to 0. Okay? Most of the time it works, but sometimes it doesn't work. Okay? So for part I, when your T is equals to 0, you're going to have 10,000. E, anything multiplied by 0, just going to give you 1. So it's going to be $10,000. Okay, so means when he first bought the motorcycle, his motorcycle is actually $10,000. Okay? The value of the motorcycle after 12 months is expected to be $4,000. Calculate the expected value of the motorcycle after 18 months. Okay, so how are we going to do this? Okay, so we know that the value, we have the formula, V is equals to 10,000 E negative PT, right? And they tell us that the value of the motorcycle is $4,000. And we know that 10,000 E negative 12 months. Okay, so we know that T is 12 and P. Okay, so they want us to calculate the expected value of the motorcycle after 18 months. But we need to first calculate what P is. Right? We need to calculate what P is. So how do you think we can calculate what P is? I'm going to give you a hint which you should have already known. I'm going to divide both sides by 10,000. So I'm going to get 4 over 10 is equals to E negative 12P. How can I make P the subject of my formula? Because I want to find the value of P, right? So how can I do that? Clue, hint. You're going to use logarithms. You're going to use logarithms. Some of you look so confused. Right? So how are you going to do that? I give you another hint. Log E base E is equals to 1. What do you have to do on both sides? What do you think you have to do on both sides? Log E, yes. Okay, so what you want to do is you want to log E on both sides. So what's going to happen to this negative 12? It's going to go down, right? Log E is just ln 4 over 10 is equals to negative 12p ln E. Ln E is just basically 1. Okay? So you know that P, in this case, is going to be ln 4 over 10 divided by 12. Can you enter this in your calculator? Absolutely. You have the calculator over here. The ln is beside the log. Can you enter it? Ln 4 divided by 10 divided by negative 12. So you know your value of P is 0.0763575. This one don't leave to 3-sig. Don't leave to 3-sig. You want to leave to more decimal places because this is not your final answer. It is your intermediate answer. Alright, so you want to leave to more significant places. Alright, I'm going to pause here for a moment. After you have found P, substitute it back into the original equation. Can you try? Substitute it back into the original equation, and then I want you to answer the question. Okay, so I substitute back means my new equation is V 10,000 E negative 0.076357 T. So can we answer the question now? What is the expected value of the motorcycle after 18 months? So what is our answer? Okay, can you try by yourself? When you're done, you look up and check your answer with mine. Okay? Okay, this one you need to be very careful. Money always leave to 2 decimal places. Okay? Yes, John, got a question? Okay, wait. I'm almost done already. Just 3 more minutes, then after I'm done already. Alright, so this is the expected value after 18 months. Okay? Is everyone okay? Okay? The next one, the last one, the age of the motorcycle to the nearest month when its expected value will be $1,000. So same thing, just substitute it in and let's see where it goes. Alright? So I know that the value is going to be $1,000. This is going to be 10,000. E negative. I know my value of P is 0.076357 T. Right? So same thing here, same thing over here. Can you find what is the value of T? Just use the ln. Right? You're going to ln both sides. Ln is log base E. Okay? So you divide both sides by 10,000 first, and then you ln both sides. When you're done, you look up and you check your answer with mine. Alright? So Jordan, after you got your answer, then you can make your way to the toilet. Hey, this question will definitely come out one. Okay? This question will definitely come out. So you better make sure you know how to do it. Okay, so your answer to 3 sig fig should be 30.5. 2. Right? Okay? Any questions for this one? Oh, they say leave the nearest month. Okay, then it's just 30 months. If it's the nearest month, then it's just 30. Okay? This question sure come out one, okay? There is no second guessing about this one. Definitely will come out. Alright? Okay, if not, I will pass you the second notes. We're going to continue after this. But don't worry, I'm not going to continue now. Alright? Just pass to you first. This one I promise you is the last set already. Yes.
Regarding the
Yeah.
I think I can go on Thursday because the drama Mr. Chu or Mr. Chu is coming to watch it with me on Wednesday.
Oh, okay lah. Then you. Okay. Who else wants to go for the VI thing?